Principles of Flight. This is taken from the Pilot's Handbook of Aeronautical Knowledge, or PHOK, Chapter 4. I asked my little nephew, why do planes fly? And he said, because they have wings. Many of you will give the same answer. Now the question is, how does a wing work? Well, when the wing is in motion, the flow of the air on top of the wing creates a low pressure, and the air flowing below the wing creates a high pressure. The difference of these pressures create what we call lift. You will ask, how do you make a low pressure on top of the wing and high pressure below the wing to create lift? To answer that, let me tell you about this man named Daniel Bernoulli, who was a mathematician and a physicist of the 18th century. Let me tell you, he did not invent the airplane, by the way, but he came up with an idea how fluids behave. He said, if a fluid is flowing inside a cylindrical and straight pipe, the pressure and speed at the beginning of the pipe will be the same as the pressure and speed of that fluid coming out at the other end of the pipe. Makes sense, right? But what will happen if we narrow a portion of the pipe? The previous statement will still be true. However, in the narrow portion, the velocity of the fluid will increase and its pressure will decrease. And that's what we know as the Bernoulli's principle. So, how is this Bernoulli principle produces lift? To answer that, we need to learn about an airfoil, which is simply a fancy word to call the shape of a wing. The airfoil can be symmetrical or asymmetrical. This old Bucher has a symmetrical wing, by the way. Looking at this cross-section of an asymmetrical wing, we can identify some of its parts. The leading edge is the front of the wing. The trailing edge is the back of the wing. If we draw a straight line between the two, we get the core line. The top of the wing we will call camber of the upper surface, and the bottom the camber of the lower surface. The imaginary line that divides the cambers in equal areas is called mean camber line. This airfoil looks very much like the half of a venturi. The air that flows on top of the surface travels faster than the air that flows over the bottom surface. And that is what creates the low pressure on top and the high pressure on the bottom. The way the air is impacting the wind is called relative wind. Here are some airfoil designs. The early airfoil is designed to create a lot of lift, but not much speed. The later airfoil provides a little less lift, but it gives a bit more speed. The Clark-Y airfoil, which is common in GA airplanes, is a good compromise between lift and speed. The next one is almost symmetrical. That is called a laminar flow and is designed to give better speeds. The circular arc and the double wedge are for supersonic speeds. The area of low pressure on the airfoil, it is called center of pressure, and it's represented in blue here. The angle between the airfoil and the relative wind is called angle of attack, or AOA. When the angle of attack is negative, notice the low pressure occurs on top and on the bottom of the wing, and the high pressure occurs on the front and upper portion of the airfoil. And it happens when we are on a descent. In normal straight and level cruise, the angle of attack is positive and the low pressure is on the upper surface, and the high pressure is on the lower surface. If the angle of attack is high and less than its critical angle of attack, then the low pressure, or CP, is almost to the front of the wing. Have you ever wondered why some wings have a fin that goes up when you fly these airlines? Well, this fin is called a winglet, and it has a very special purpose. Remember, in normal cruise, we have all the low pressure on the top of the wing and the high pressure at the bottom of the wing. Well, the wind doesn't go on forever. That means the wind is not infinite. And these two pressures also join at the end of the wing, and they produce a tip vortex. And it's caused when the high pressure wants to go over the low pressure area on top of the wing. And that's all for now, folks. I suggest watch this video again and remember the concepts of the words we learned today. Have a good day.